In this example, we're going to solve this linear system using substitution. So the first step is to choose one of these equations and go ahead and solve for one of its variables. So it looks like maybe this second one, 3x minus y equals negative 5. I'm going to take this negative y, I'm going to bounce him over to the right side to make him a positive y. And then this negative 5, I'm going to go ahead and add 5 to both sides, and I'm going to put him on the left side. So I have this 3x plus 5 equals y, and that came from the second equation. So I have this expression 3x plus 5, and I know that it's equivalent to y, so I'm going to go ahead and substitute it in for y, but in the other equation. So this y will become 3x plus 5, and then I have the minus 2 equals 3x plus 1. Okay, so now you can use the distributive property, and it's just a matter of solving this equation. So 3x plus 3 equals 3x plus 3. Well, that's interesting. So if I were to subtract 3x from both sides, my variables completely cancel out, and I'm left with a numeric statement, 3 equals 3. Well, this is a true statement, so I know that when all the variables cancel in an equation and I'm left with a true statement, I know that I'm going to have an infinite number of solutions. So that's also good for the system as a whole, which means if it has infinite solutions, these two lines, if I were to graph them, are actually the same exact lines. They would be coincident, one on top of the other. So that means that every solution of one equation is also a solution of the other equation. So this system then has an infinite number of solutions.